OpenSciEd, Inverter Magnet Demonstration, Student-Facing Video. Two small silver button magnets lie on a desk about 4 inches apart.
These magnets will represent the nuclei of two different atoms. The electric forces between two positively charged nuclei should repulse each other.
The speaker pushes the two magnets towards each other. They are repelled from each other and slide away.
Let's test how the magnitude of this force varies with distance by placing one of these magnets in a plastic holder and attaching a spring scale to it.
The speaker moves the other magnet toward the one attached to the spring scale. The magnets repel each other, and the spring scale compresses by a few newtons.
What relationship do you notice between the distance between the magnets and the forces acting on them?
As the speaker moves the magnets closer, the more the spring scale compresses.
We will use a smaller magnet to represent an electron of an atom. The electric forces between this and a positively charged nuclei should attract each other. The opposite face of the smaller magnet has been flipped around to simulate this electrical force interaction with a magnetic one.
A tiny magnet snaps to the button magnet.
To simulate the structure of an atom, we've placed one nuclei in the center of this plastic holder and some electrons around its center. In a moment, we'll bring the positive nuclei of a second atom closer to this first atom to simulate what happens when bonds form through the sharing of pairs of electrons between two atoms. Before we do this, predict what you think the net force will be on these parts as we bring them together.
A button magnet is placed in a plastic ring with 6 tiny magnets around it. The speaker moves a second button magnet towards it.
Forces in the system stabilize the parts at a distance of about 4 millimeters apart. This distance represents the stable bond length that these bonded atoms would form. Different atoms would form different strength bonds and therefore different bond lengths.
The second magnet nearly touches the first with a very small gap between them.
Notice how the strength of the repulsive forces increases as we push them together, which returns it to a stable bond length. And the strength of the attractive forces increases when we pull them a little bit apart, returning it to a stable bond length.
The video ends. OpenSciEd.